Welcome to the Basic Foundation Physics lecture series. This is our lecture number 2, and in this lecture we are going to learn more about vectors and kinematics. The topics that we are going to cover in this particular lecture are addition of two vectors, uniform and non-uniform motion, acceleration, and kinematic equations of linear motion. Yes, so we had already discussed in our last lecture that the algebras for scalar quantities and vector quantities are completely different. We cannot apply the laws of simple algebra when we deal with two vectors. If we have two masses m1 and m2 and value of each mass is 2 kg and we have to find the total mass of the system, so it will be equal to m1 plus m2 and which is equal to 2 plus 2 which is equal to 4 kg. So we know that mass is a scalar quantity, so when we add two scalar quantities we simply add their magnitudes to get the final result. But the interesting thing is, when we add two vectors, let's say we have two force vectors and magnitude of each of them is equal to 2 Newton and the angle between them is theta, where theta could be anything between 0 to 180 degrees. So in this case, magnitude of their vector resultant, magnitude of their vector addition could be anything between 0 to 4 Newton. This is the minimum value of magnitude of their resultant, while this is the maximum value of magnitude of their resultant. We will get this value for theta is equal to 180 degrees and we will get this value for theta is equal to 0 degrees. How we have obtained these values will be discussed later, but for now what we have to keep in our mind is that when we add two vector quantities we don't simply add their magnitudes. In this case we are adding two vector quantities each having a magnitude of 2 Newton, but the magnitude of their vector addition is not always equal to 4 Newton, which is the addition of their magnitudes. We are going to learn these rules, we are going to learn how to add two vector quantities in a while, but for now what we have to keep in our mind is that when we add two vector quantities we don't always add their magnitudes. Yes, so let us now learn the rules for vector addition, and the first law of vector addition is triangle law of vector addition, according to which if two vectors are represented by two sides of a triangle taken in the same order, then the resultant of these two vectors will be represented by third side of the triangle taken in the opposite order. In this diagram, vectors a and b are being added, and these two vectors are representing two sides of a triangle, and the third side of the triangle is the resultant of these two vectors, and resultant is nothing but the addition of these two vectors. This point over here is the tail of vector A. This point is the head of vector A. This point is the tail of vector B. This point is the head of vector B. This point over here is the tail of resultant R, and this point over here is the head of vector R. This will help us in understanding triangle of vector addition more clearly. So what we are going to do, we will first fix any vector and then we will place the tail of the second vector over the head of the first vector, and then after that we will join tail of the first vector to the head of the second vector. Let's take an example. We have to add vector A and vector B, and the angle B is making with horizontal direction is theta. So first we have to fix any one vector keeping its magnitude and direction fixed. So this is vector A, and from horizontal direction B is making an angle theta. So here we have placed the tail of vector B over the head of vector A, and this third side will give us the resultant of these two vectors. So we have joined tail of vector A to the head of vector B, and this is the resultant of these two vectors. In this case, we can also fix the vector B, and now we have to place the tail of vector A over the head of vector B, and this third side of the triangle will give us resultant. It doesn't matter which vector we take first, we are going to get same result in the both cases. We had discussed in our last lecture that when we represent a vector by an arrow, so the length of the vector gives us the magnitude. So magnitude of this vector is equal to length of this side of the triangle. Magnitude of vector B is equal to length of this side of this triangle. And the length of this side of the third side of the triangle will give us the magnitude of the resultant. So if we are naming these points as O, P and Q, so magnitude of A will be nothing but the distance between points O and P. Magnitude of B will be equal to distance between point P and Q, and magnitude of vector R, which is the resultant of these two vectors, will be equal to distance between points O and Q. So clearly we can say that in this triangle OQ is not equal to OP plus PQ. So magnitude of vector R is not equal to magnitude of vector A plus magnitude of vector B. So when we add two vector quantities, we don't always add the magnitudes of two vectors to get the magnitude of resultant. We will now take two cases when theta is equal to 0 degree and theta is equal to 180 degrees. So when value of theta is 0 degrees, in this case we can say that the two vectors are acting along the same direction because angle between them is 0 degrees. And if we apply triangle of vector addition here, so we will fix one vector keeping its magnitude and direction fixed, and we will place the tail of second vector over the head of first vector. And if we join tail of first vector to the head of the second vector, then we will get the resultant. So here also we are naming these points as O, P and Q, and length of vector A is distance between points O and P, which is also equal to magnitude of vector A. Length of vector B is equal to distance between points P and Q, and length of vector R or magnitude of vector R is equal to distance between points O and Q. So in this special case when theta is equal to 0, we can clearly see that OQ is equal to OP plus PQ. So in this case magnitude of R is equal to magnitude of A plus magnitude of B, or R magnitude of R is equal to magnitude of A plus magnitude of B. So we can conclude that we can add magnitudes of vector A and vector B only when the angle between two vectors is 0. Now we will see what will happen when the angle between them becomes equal to 180 degrees. So this is our vector A, and Vector B in this case will point in the opposite direction to vector A, and we will fix first vector, and then we will place the tail of the second vector over the head of the first vector. So this is our vector B, and when we join tail of the first vector to the head of the second vector, then we will get the resultant. Here also we will name these points as O, P and Q, and we had already discussed it earlier. Magnitude of A, which is equal to length of this vector, will be equal to distance between points O and P. Magnitude of B will be equal to distance between points P and Q, and magnitude of R will be equal to distance between points O and Q. So in this special case, when angle between these two vectors is 180 degrees, we can clearly see that OP is equal to OQ plus QP, and OP is the magnitude of vector A, OQ is magnitude of vector R, and PQ is magnitude of vector B. So in this case, when theta is equal to 180 degrees, magnitude of vector R is equal to magnitude of vector A minus magnitude of vector B, or we can write this as R is equal to A minus B. So when theta is equal to 180 degrees, then we will subtract the magnitudes of two vectors from each other to get the magnitude of resultant. So here we are combining all the possibilities. So this is our vector A, and this is our vector B, and we are considering all the possibilities here. So in this case, when angle between vector A and vector B is 180 degrees, the length of these 2 points will give us the resultant, and in this case the length of these 2 points will give us the resultant. In this case, when we join these 2 points, length of these 2 points will give us the resultant, and when vector B is acting in this direction, then length of this vector will give us the magnitude of resultant, and in this case, when theta is equal to 0, length of this vector will give us the magnitude of resultant. So we can say that when theta is equal to 180 degrees, the length of resultant is minimum, and when theta is equal to 0 degrees, the length of these 2 points is maximum. So we can say that the value of resultant will be greater than or equal to its minimum value, or it will be less than or equal to its maximum value, and we will get minimum value of magnitude of resultant when theta is equal to 180 degrees, and we will get the maximum value of magnitude of the resultant when theta is equal to 0 degrees. And we have already derived here that for theta is equal to 180 degrees, uh, the magnitude of resultant is the subtraction of magnitudes of two vectors, and we are putting a mod sign here because we will take the positive value, and value of magnitude when theta is equal to 0 is equal to addition of magnitudes of two vectors. So value of R will be always greater than A minus B, and it will always be less than or equal to A plus B. Now go back to our first example. So in this case, two forces of equal magnitudes 2 and 2 are acting at an angle theta, and value of theta is between 0 to 180 degrees. So in this case, the magnitude of resultant will be equal to subtraction of magnitudes will be greater than or equal to subtraction of magnitudes of these two vectors, and will be less than or equal to addition of magnitudes of these two vectors. So a magnitude of resultant will be greater than 0 and less than 4 Newton in this case. So let's go back to our very first example. So in this case, two forces of equal magnitudes are acting at an angle theta, and value of theta is between 0 to 180 degrees. So we can now say that magnitude of their resultant will be greater than or equal to subtraction of magnitudes of these two vectors, and it will be less than or equal to addition of magnitudes of these two vectors. So value of resultant will be greater than or equal to 0 Newton, and it will be less than or equal to 4 Newton. Let us solve a question based on triangle of vector addition. So in this question, a force of 2 Newton is acting along east direction, and another force having the same magnitude is acting along north direction, and we have to find the magnitude of their resultant. So we will first draw these two forces. So vector F1 is acting along east direction, and its length is equal to 2 Newton, and vector F2 is acting along north direction, and its length is also equal to 2 Newton. This is vector F2. So from triangle of vector addition, we will first fix any vector, and then we will place the tail of second vector over the head of the first vector, and to find the resultant we will join the tail of first vector to the head of the second vector. So this is our resultant, which is equal to vector F1 plus vector F2. So here we are naming these points as O, P and Q, and in this triangle length of OP is 2, length of PQ is also equal to 2, and the angle between these two sides of the triangle is equal to 90 degrees. So we can apply Pythagoras theorem here. So OQ square will be equal to length of OP is 2 and length of PQ is also equal to 2. So OQ square will be equal to 2 into 2 square. So OQ will be root 2 times 2. And the distance between these 2 points OQ is nothing but the length of third side of the triangle, and it is equal to magnitude of vector F1 plus vector F2, which can be written as mod R or simply R, and in this case it is equal to 2 root 2 Newton. I request you all to try these examples on your own so that you get comfortable with these new rules. We will just stop here, and we will learn more about these rules of vector algebra in our later sections, but for now we will discuss a few concepts of kinematics. So we have discussed that the rate of change of distance is called speed, and the rate of change of displacement is called velocity. And now we have to learn about acceleration. So the definition of acceleration is defined as the rate of change of velocity. So the rate at which velocity is changing is called the acceleration of that particle, and it is a vector quantity, and it is denoted by vector A. So acceleration is change in velocity upon time. So acceleration is change in velocity, so change in velocity will be equal to final velocity of the object minus initial velocity of the object upon time t. So if in a time interval t, velocity of an object is changing from vector u to vector v, that is vector u is the initial velocity of the object and vector v is the final velocity of the object, then acceleration of the particle in that time interval will be defined as vector v minus vector u upon t. So this is a vector subtraction. So we cannot apply the simple laws of algebra here, because we have already discussed that the laws of algebra for vectors are completely different. So we will learn how to subtract two vectors in our later sections. But for now, please keep this in mind that this is a vector subtraction. Magnitude of acceleration will be magnitude of change in velocity upon time, and direction of acceleration will be along the direction of change in velocity. So based on the acceleration, uh, we say that if acceleration of any object is zero, then it is said to be moving in a uniform motion, and for non-zero acceleration, an object is said to be moving in a non-uniform motion. Since the acceleration of the particle moving in a uniform motion is zero, so we can say that velocity of this particle will be constant, and for a particle moving in a non-uniform motion, its velocity will not be constant, or we can say that its velocity will change with time, or we can say that its velocity is variable. You will also come across a term uniform acceleration or uniformly accelerated motion, which is defined as the motion having constant acceleration. So if acceleration is constant, then the motion is said to be uniformly accelerated motion. And for the non-uniform acceleration, acceleration is not constant with time. So after learning definitions of displacement, velocity and acceleration, we will now study few relations which relate these different physical quantities. The equations which relate these different physical quantities are known as kinematic equations of linear motion. And for constant acceleration, equations of motion are v is equal to u plus at, s is equal to ut plus half at square, and v square is equal to u square plus 2as. In these equations, v is the final velocity of the particle, u is the initial velocity, a is acceleration of the particle, s is the displacement of the particle, and t is time taken by the particle. So the first equation relates final velocity with initial velocity, acceleration and time, and this equation is independent of displacement. The second equation relates displacement with initial velocity, time and acceleration, and this equation is independent of final velocity of the particle. And the third equation relates final velocity with initial velocity, acceleration and displacement, and this equation is independent of time. While solving the problems, one of the important thing that we have to keep in our mind is that velocity, acceleration and displacement are vector quantities. So we have to substitute their values with proper sign. For example, if velocity of any particle is in this direction and its acceleration is in the opposite direction of the velocity, then we can assume any direction to be positive. So let's say if we are taking this direction to be positive, then while substituting the values of velocity and acceleration, velocity will be substituted with positive sign and acceleration will be substituted with the negative sign. If we substitute expression of acceleration from equation 1 into equation number 3, then we will get an equation which is independent of the acceleration. So from equation number 1 we can say that acceleration is v minus u by t, and we can substitute this expression of acceleration in equation number 3. So equation number 3 is v square is equal to u square plus 2s, and a is equal to v minus u by t. So we can modify this equation. So v square minus u square will be equal to 2 times v minus u by t into s, and we know that a square minus b square is a square minus b square is a minus b into a plus b. So v minus u will get cancelled, and v plus u will be equal to 2s by t. So from this equation we will get s is equal to v plus u by 2 into t. So this equation is independent of acceleration, and it relates displacement with initial velocity, final velocity and time. And from this equation we can say that s by t will be equal to v plus u by 2, and we know that s is displacement, s is total displacement, and t is time taken. So total displacement of the particle, t is time taken by the particle, and we also know that total displacement covered by the particle upon time is nothing but average velocity of the particle. So when a particle moves with a constant acceleration, its average velocity is equal to v plus u by 2.